Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to try to find horizontal and vertical tangent lines to the given curve if they exist, obviously. And we have a specific curve, in fact, a very special curve provided to us. That has the parameterization x equals 2t and y equals 2, 1 minus cosine t. And we are given only some portion of that, which is the portion stuck in between t equals 0 and t equals 2 pi. And this is also another classical problem that we tackled in Calculus 1. Once the rectangular equation is provided to us, we were able to find the vertical and horizontal tangent lines if they exist. And now we have the parametrized curve version of this. And obviously, horizontal tangency happens when the slope of the tangent line is 0. And vertical tangency happens if that exists. Then the slope should be undefined. So we're going to sort of like dive into this problem again for this curve and see the details of that. I don't want to give you more heads up, but by just looking at the graph, you can actually read out where the horizontal tangency occurs. And it seems like there's no vertical tangency by just looking at the graph of that. But we're going to do the analysis in the rest of the video. All right, let's get started. All right, let's take care of this. We're going to find all the points of horizontal and vertical tangency to the portion of the curve here. So this is a periodic curve corresponding to the t-values in between 0 and 2 pi. And all we need to remember from Calc 1 is that you have a horizontal tangent line when the slope is 0, and you have the vertical tangent line when you have the slope undefined. By in fact, looking at the curve here, I can see horizontal tangent lines at different locations here, right? But I can't see any vertical tangent line around, and we should probably verify that with our analysis, okay? So what I'm going to do now is to look at dy over dx and see what t values correspond to those horizontal tangent lines, and we will discuss about why we don't have vertical tangent lines. And here we go. I'm going to look at dy over dx, which is dy over dt, dx over dt. This was the trick that we used to use earlier, dividing top and the bottom of dy over dx by dt, so that we can take the individual derivatives of y and x. So this would be, well, this is 2 minus 2 cosine t, so it's going to be 2 sine t divided by 2, and 2's cancel. Okay, 2's cancel, and we got just sine t for dy over dx. And for horizontal tangent lines, since this represents the slope, let me just write here that this represents the slope. I'm going to set this to 0 for horizontal tangent lines, okay? So let me just write here that for horizontal tangent lines, dy over dx is supposed to be 0. So that's us solving this trig equation, okay? Sine t equals 0. Okay, so go ahead and pause the video and please solve this equation. Yeah, you can look at arc sine 0, but that's going to be only one value. So you can't just rely on your calculator for finding arc sine 0 because we have multiple theta values at which we have a horizontal tangent line here. Okay, so we have to find those like different locations here. Okay, so essentially you can have a unit circle here and then check what kind of like theta values take you to sine equals 0. So and do your analysis, and then you should be able to get t equals 0, pi, and 2 pi. And in fact, this goes on and on because we were talking about integer multiples of pi making like sine 0, but since the interval given in the problem for t is 0 and 2 pi, so we can only go that far. Okay, so we have 3 candidates in that regard. And as you see, like sine t is defined everywhere. And I can go ahead and write that their vertical tangent lines does not exist because sine t is defined everywhere. For vertical tangent lines, we should have the slope undefined, but this is not the case for this problem. Okay, so we have let's see, we found the t values, so that why don't we go ahead and find the points corresponding to those. Okay, so let me just erase this part. For t equals 0, while I erase this portion, you can work on plugging in 0 for t in x and y. So t equals 0, you have the point 0 and 2 times 1 minus cosine 0. And go ahead and punch this into your calculator and get 0 in the output, because cosine 0 is 1 and 1 minus 1 is 0. Okay? For t equals pi, we have 2 pi. Okay? And then we have 2 times 1 minus cosine pi. Here we go. Cosine pi is -1. 1 minus 1 is 2, so this should be 4. And for 2 pi, there's something interesting going on here. Let's see. In fact, not really. Okay, good. For t equals 2 pi, I have x equals 4 pi. And y equals 2 times 1 minus cosine 2 pi. And cosine 2 pi is 1. 1 minus 1 is 0. So you're talking about the point 4 pi and 0. This was the third point in the graph. And now let me just put a bigger graph here just to show you what's going on. So the origin that we got is right here, that corresponds to t equals 0. And this is the point where we got like 2 pi and 0, and this was in fact 0 and 0, and that's what we have here. Horizontal tangent line, which is this one, right? And at t equals 2 pi, which is right here. Let me just move this a little bit. Okay, I'm just putting this part. And as you see that at t equals 2 pi, you have another vertical tangent line, horizontal tangent line that comes with the coordinates 4 pi and 0. Okay. So we have three of them in total, so that we have all figured out. Let me just go to the smaller picture here, just to see the full picture. That you have 3 horizontal tangent lines happening in the graph, right? And no vertical tangent line. All right, so this is the end of the video. If you have any question or comment or even suggestion, please send those to my way. I'm happy to address your comments or suggestions. Thank you so much, and I'll see you in another video. Bye.